Today in the Universe Sandbox simulator, I'll fire a powerful space laser and melt the polar caps of the red planet. Let's see how this changes Mars, if the temperature rises, if a dense atmosphere appears, and if the planet can take a step toward terraforming, or if everything goes completely off plan. So I've opened the laser tool in the Universe Sandbox simulator, and I'll choose a laser type. I really like this laser here, Hot Magic. I'll select it, start the time, and we'll have 15 days passing every second. And so, I'm starting to melt the polar ice caps of Mars. So basically everything cools down quickly because the time is fast forwarding. We see that some kind of atmosphere and gases are being released in the places where I used the laser, but it's all freezing up again quickly. The temperature on Mars only rises for a short time. As we can see, yes, in the spots where I scorched Mars with the laser, the temperature is even over 100 degrees. There it is. But after a while, everything here cools down to a level where liquid water appears, and most likely not for long, because we see that the temperature is actively cooling down, and apparently everything is going to freeze. But right here, for a moment, even some life manages to form. There was a green strip right there. In the southern hemisphere, as we can see, it is all gone. However, some temporary liquid bodies of water have appeared. And now the maximum temperature will drop below zero, and these bodies of water will definitely freeze. I've sped up time even more, 1 month per second now, and we see that everything has finally frozen. And the only change on Mars is that its ice caps are now more noticeable than they were before. That's not all. Now my laser's power will be 10 times stronger, and its radius, I'll also double that. And I'll also give Mars a good magnetic field so that all this atmosphere stays and isn't blown away by the sun. I'll set the magnetic field strength to 1 Gauss. And as you can see, Mars now has a magnetic field. Now I'm going to melt the polar caps of Mars with a much more powerful laser. I've opened the parameters for the Martian atmosphere. Look here at how the atmospheric characteristics are changing. Anyway, I'm starting to melt these polar caps of Mars with a much more powerful laser. Oh, and as we can see, the pressure and atmospheric mass are rising. Wonderful. More and more intensely. I'm going to melt the ice caps. Now, I'm also not forgetting about the southern hemisphere. The ice caps are smaller here, but they still need to be melted. I'll hit half the planet like this, just like that, to make sure everything melts there. And I'll add some more here in the northern hemisphere. Oh, look at those dense clouds forming. The more I heat the polar regions like this with the laser, but still. As soon as I cease the heating process, the atmospheric pressure on the planet starts to drop very rapidly. And the atmospheric mass is decreasing too. In terms of temperature, we see that only in the spots I heated is it over 100 degrees Celsius. If we look at the atmospheric composition, it was mostly water vapor that predominated here. There are very few other elements. Now let's take a closer look at what exactly happened here with Mars. Whoa, we have vegetation right at the North Pole, but it only appeared for a moment and then vanished. I'm turning on the display for the atmosphere and clouds. Actually, there's no need to hide them, the surface is still clearly visible. A few small bodies of water remain here, but they'll freeze over time. In Mars' southern hemisphere, as you can see, all is already frozen. The North is holding out longer for now, but all will eventually freeze here too. There, I've sped up time, and now it's completely frozen over. And so, this is the Mars we get, now with even more pronounced ice caps. But that's not all, guys. I've come up with a really great idea on how to heat up Mars. I'll give it a second companion, an object that will orbit very close to the planet and heat it up through tidal forces. This will result in a binary planetary system consisting of Mars and a second body orbiting a common center of mass. And I'll place this object at a distance of 15,000 kilometers from Mars. I've added such an interesting companion to Mars. It has a lot of water on it. Its mass is nearly 3 times that of the Moon, with a radius of 2,237 kilometers. I'll select these two objects and add a barycenter for them. And here's what we get. The barycenter is somewhere right here. I'm starting the time, so let's see how it all moves. Mars's moons Phobos and Deimos are here too. This second companion will likely just scatter them away, or perhaps one of the moons will even collide with it. Anyway, let's see what happens next. Mars and this object have begun orbiting their common center of mass. Phobos is already drifting into a much more distant orbit around Mars, and everything has become clear now. Regarding Mars's moons Phobos and Deimos, Phobos has broken away and is now simply orbiting the Sun, while Deimos is just orbiting far away from these two objects. Though right now it looks as if it's already been pulled away, so it seems Mars is left with only its new second companion. While Mars continues to travel along its own orbit around the Sun, time is passing at 10 hours per second. As seen from the recorded temperature data, the temperature rises every single time the second object reaches its closest point to Mars in its orbit. So, let's find out exactly what the final temperature will be. We'll have to pause for a moment. Look at what's happening to the second companion. Its atmosphere, as I understand it, is starting to simply fall apart or something. It's become a bit flattened like that. Well, yes, Mars's gravity is definitely having an effect. And as we can see, this object has a lot of water vapor in its atmosphere, and that's likely what's evaporating. But I assume these particles could still reach Mars and provide it with even more water. That would be pretty good, wouldn't it? Don't you agree? If we speed up time even more like this, look at the cloud just flying off from this object. It's enveloping Mars, and water particles are actually falling onto the Martian surface. This object has changed significantly. Its atmosphere here has become very dense. There is no liquid water left on the surface. Recall the water I showed you earlier. It has now simply evaporated into the atmosphere. The temperature on this object exceeds 300 degrees Celsius across the entire body, and there's a huge amount of water vapor in its composition. Now I'll speed up time to 1 day per second. Checking the atmosphere parameters, it is mostly ammonia evaporating now. That's it, the ammonia is gone. And now I see that water vapor is also evaporating. So, little by little, the entire atmosphere is still evaporating. And if you zoom out here, look at this cloud, it's insane. Also, by the way, I forgot to give Mars a magnetic field. I'll set the magnetic field strength to 1 Gauss. It's better for Mars to have a magnetic field in this experiment. Anyway, let's keep watching to see what happens to Mars's temperature. The average temperature, as you can see, has already risen above 0 degrees. Right now, about 5 hours per second are passing in the simulator, and the temperature is still continuing to increase, but I'm worried about this gas cloud that's enveloping Mars. I'll make it so that it's not here anymore. Basically, I'm going to delete all these particles, and for this object's atmospheric composition, I'll completely zero out the water vapor. Look how the object changed instantly, and we see it's glowing hot there on the surface. If I speed up time, it seems like no more particles are appearing, but we see that the molten rock of this object nicely illuminates the dark side of Mars. And let's continue watching how the temperature changes. At the moment, 10 hours per second are passing, and the average surface temperature has already exceeded 20 degrees. I don't really like this. I see I'll have to move this second companion further away because it's heating Mars too much. This object's orbital period around Mars is just under 10 hours. I'll increase it to 11 hours, so it'll orbit a bit further from Mars. I'm starting the simulation. Let's see how the temperature behaves now. Hopefully it'll be better. No, I still see that our temperature is continuing to rise further. So for this object, I'll set the orbital period around Mars to 13 hours now. Starting time. And I see that the temperature seems to have stabilized, I guess. No matter what time I set in the simulator, whether it's 4 hours per second, 7 hours per second, or 10 hours per second, the temperature stays the same. Oh, it dropped a little bit. What if I try to speed up time even more? Well, you see, the simulator works in a way that when you set it to say 20 hours per second, the temperature now you see is falling. If I slow down the time flow in the simulator, the temperature might actually start rising instead. There, I've set it to 5 hours per second. In this situation, the temperature isn't falling after all. Oh well, then I'll speed up time significantly, and let's have a full day pass per second. And in this case, it's already over 17 degrees Celsius and continuing to drop. Let's see. Now I'll try slowing down the time flow in the simulator. 15 hours per second, still dropping. I'll bring it to 10 hours per second. Well, at this time flow rate, the temperature isn't changing at all. And now I've set it to 3 hours per second, and we see the temperature is steady. I don't even know what to do, either speed it up, but the more you speed it up, the less accurate the simulation's calculations become. So maybe this is the truth, that the temperature is stable now. Anyway, let's just leave it like this, and I won't bother with it anymore. That's settled then. Now I'll take the laser again, this more powerful one that I used before, and I'll melt the polar ice caps on Mars again using it. Look at those clouds appearing on Mars already, cool. Now for the southern hemisphere, but I see there are no glaciers here at all. But I'll still dust the surface of Mars a bit with the laser here. It won't hurt, I think. So what do we have here? Let's add some more here. That won't hurt either. In general, a fairly dense atmosphere seems to be appearing. Let's see what happened with the atmosphere. We have a bit of argon, a bit of carbon dioxide, but the main component on Mars here is still water vapor, and there's a little bit of nitrogen. In the ocean, there's even liquid sulfur dioxide and liquid oxygen. Wow. There is of course water and a little bit of ammonia, and it shows that there's still some water ice somewhere. The pressure is 0.22 atmospheres, and the atmospheric mass is 34 times, greater than what Mars had before. I'll set the simulator to 1 day per second, let Mars cool down, and then we'll see what Mars turned out to be in the end. And so, as we can see, the average temperature has already returned to the values we had before using the laser. But the maximum temperature is still huge. Anyway, I'll slow down time now and see how the temperature behaves. I set it to 10 hours per second and we see that yes, the temperature has simply stabilized. I could speed it up more than 1 day per second, but then this second component would simply break away from Mars. I've already tried doing that off camera, believe me. So now I don't even know what to do. Let's take this maximum temperature and make it reasonable using manual settings. Back then it was somewhere around 40 or 50 degrees. I don't remember exactly. Let's say 45 degrees Celsius. Our average temperature has become 6 degrees. And it's even started to rise. There the temperature has reached almost 8 degrees Celsius. That's enough. I've hidden the atmosphere and clouds. Now I'll show you the temperature at various points on the planet. In general, it's warmer in these bodies of water. When I point to the land, it's cooler here. Let's look at the poles now, but I can see Mount Olympus. It's very cold over there. Minus 72 degrees. And the nearby mountains are also cold. At the base of the volcano, it's 4 degrees Celsius. And what do we have here at the North Pole? 38 degrees. Wow, that pole has really heated up. Well, that's a feature of tidal force friction. The temperature can be fairly even all across the planet. Even in the southern hemisphere at the South Pole, it's also very warm. Well, I thought I was imagining it, but no. Mars's rotation period has sped up, and a day on Mars is now just over 8 hours. Wow, this is likely because the second component has simply locked it to itself on one side. Or maybe they've both synchronized or something. Let's look at this second companion now, and we see its day is 9 hours, so not the same as Mars. I'm curious about one thing, and I think you will be too. I'll go down to the dark side of Mars and see how this second companion looks. There it is actually. I'll speed up time even more. And as we can see, this second companion will set below the horizon on Mars. This means that it doesn't have a geostationary orbit here, and it still moves across the sky. But still, it had a good influence on the day on Mars, which spun it up so much. For those who don't know, Mars used to have a 25-hour day, and now it's just over 8 hours. As a result, the pressure on the surface of Mars is 0.23 atmospheres, and the probability of life is tiny, at only 2%. Now I'll hide the atmosphere and clouds and try to find some vegetation somewhere here. What if it appeared somewhere here? What if? No guys, after searching very thoroughly, I didn't find it at all. And we see what kind of eclipse Mars creates on this object. Now I think it wouldn't hurt to descend to this object and look at Mars. There's Mars, it doesn't shine through the clouds very well. But now night is falling, and Mars is so huge here in the sky, and the clouds are covering Mars a little bit like that. It looks pretty good, of course. So we've seen what happens to Mars if you melt its ice caps and further heat the planet with tidal forces from another object. If you liked the video, don't forget to like it and leave a comment. I'll be very interested to hear your opinion. Thank you very much.